Welcome, welcome everyone. Here I am. Okay, so here you are in Granada, at least. This is how Granada it is. Bonjour tout le monde. Bienvenidos a todos. I feel like in the Eurovision context right now. So come with me because I'll make some introduction to before having the Calar Alto virtual visit. Some of you asked us how the weather was like in Granada, how was the feeling of being in Granada at this moment right now. So I thought of walking with you, at least in Zoom, in this sunset to transmit this feeling of how it would be to make a real visit to the Calar Alto Observatory, which is very near Sierra Nevada, among the oaks, the olive trees. I have to pick my olives. By the way, it's season time. Calar Alto Observatory is one of the best observatories in Europe. It actually has the scope continental Europe with 3.5 meter size for the primary mirror is rock and roll. It's actually the Freddie Mercury of our telescopes. So the folks in Calar Alto have sent us a video, a recorded video. The visit will not be live. It is recorded. And there will be a welcome message for the director of the observatory. And then I have here in the panelist pane of Zoom, astronomer Gilles Bergond, that will answer your questions after the visit, after I play the video. So let me grab a beer, an Alhambra beer here, and enjoy the visit with me.
Hello. We're flying over the Calar Alto Observatory, the largest optical astronomy complex in continental Europe. Using its 4 professional telescopes, we can observe the universe every night under one of the purest and cleanest skies in the world, in the service of the scientific community. We represent an international benchmark, especially in the search for exoplanets or planets that orbit around stars other than the Sun, thanks to the Carmenes instrument. Would you like to participate in a night of observation? Well, get ready, let's go down. With a mirror measuring 3.5 meters in diameter and a dome as tall as a cathedral, we welcome you to the largest optical telescope in continental Europe. Let's go inside.
Hi, welcome to Calar Alto Observatory. My name is Jesús Aceituno, and I'm the Executive Director of the Observatory. Let me introduce to this fantastic facility, which is actually a worldwide reference in astronomy. The German-Spanish Astronomical Center is actually in process of transformation into the Hispanic Astronomical Center in Andalucía. This is an economic interest group that currently operates the Calar Alto Observatory. It is a singular scientific and technical infrastructure of the Ministry of Science belonging to the Spanish Astronomy Infrastructure Network. On May 20th, in 2019, the Andalusian government and the Max Planck Society signed a participation transfer agreement, so the German partner transferred the ownership to the regional government. Therefore, as of that date, Calar Alto Observatory is managed in equal parts by the Spanish National Research Council and the Andalusian regional government, with the Instituto de Astrofísica Andalucía as our reference institution that contributes to define our strategy in science and instrumentation. Calar Alto has at the moment 4 fully operational telescopes with aperture of 3.5, 2.2, and 1.2 meters. We also have an Schmidt camera with 1.2 meter of diameter. The 3.5 telescope allocates 80% of the total observing time to the Carmenes project, and the rest of the time is offered through an international time allocation committee that evaluates all the proposals submitted 6 monthly. the 2.2-meter telescope continues to dedicate 60% of the time to a collaboration with the University of Beijing until July in 2022 for the study of supermassive black holes in galaxies with active nuclei known as AGNs. The remaining time is also managed by the same time allocation committee. The 1.2 telescope is offered in campaigns to national and international researchers and maintains a demand of use close to 100%. Previous external financing. Our Schmidt camera is devoted to the search of near-Earth objects or potential hazards to Earth. The quality of our observatory is measured, among others, by the rate of scientific publication, or in other words, by scientific results. The rate of publication in referee journals using Calar Alto data was above 110 papers in different journals, like, for instance, Science and Nature, among others, being our highest historical record obtained from Calar Alto. The observation time lost due to the technical problem was about roughly 1% for the 3.5-meter telescope and around 2.5% for the 2.2-meter telescope. These values are achieved thanks to the excellent skills and training of Calar Alto staff. Among CAHA's most important project is the CAMNES program. The main goal of this program is to monitor a total of 330 M-type stars, which could contain Earth-type planets located in the habitable zone. The CAMNES project started on January the 1st in 2016 and will last until the end of 2023. At the moment, a total of 620 useful observing nights has been allocated. There are more than 40 publications in referee journals, 24 presentations in technological meetings, 14 PhD works, and over 40 planets already discovered. An observatory is a very large scientific laboratory that needs constant instrumental improvement. For this reason, observatories are considered as a huge interdisciplinary laboratories of optics, computing, electronics, mechanics, and of course astronomy. But there are other areas where Calar Alto also may contribute. For instance, the energy needs are high because the center is located at high altitudes. For this reason, we are developing the concept of the energetic island to partially cover our energetic needs, and it comprises of 350 kilowatts photovoltaic park and an 850 kilowatts biomass boiler that will make the center's energy expenses more sustainable, reducing the CO2 emissions by 160 tons per year and optimizing the observatory's energy expenses by roughly 40%. Another example is our aluminum chamber. This facility allows us to renew our mirrors every year and continues to be an international reference thanks to collaborations with other institutions, for instance, the aluminization of the mirror of the Sunrise telescope. This telescope has been designed to study the magnetic field of the sun and is in the preparation phase, basically to be launched in 2021. Or the Herschel mission, for instance, who also was aluminized in this facility. And now I would like to give the way to my colleague, Dr. Gilles Bergond, who will surely tell you many curiosities about our beloved observatory. Thank you so much for your attention and enjoy the rest of the visit.
Many thanks, Jesús, for this nice introduction to the Calar Alto Observatory. Welcome aboard. We are inside the former control room of the 3.5-meter telescope. This is this very nice desk, old-fashioned desk, with a bunch of buttons. All of them are just working perfectly. One button, one action. It was the old way, but it's really working very nicely. And let's try to move this telescope. Let's send it right here. So from here, through the window, you can see the 3.5 telescope behind me, which is starting to move, and you can also watch this live view with the webcams inside the telescope. But finally, there is something very interesting. It's moving, but it's moving. Let's try to get inside the 3.5 dome itself. You will see and you will hear, or better say, you will not hear that this is moving silently. This is something like 260 tons moving silently. This is like 50 elephants with no noise. This is because the equatorial mount of this telescope is really huge. The design, the equatorial design means you need a big mount inside a big dome. I remember you that this dome is 42 meter height. This is as tall as the Cathedral of Sevilla, for example. It's moving silently with an excellent accuracy. Just to give you an idea, you could point on both sides of a 50-cent coin located 50 kilometers away. This is impressive, right? You can point on both sides, and also, of course, you could resolve the coin because of the excellent optics. This is a Zeiss German-made mirror and structure, everything. So we are just moving slowly to the prime focus position, and from here actually you can see the secondary mirror which is sending back the light through the whole of the primary mirror, and you can then here in the Cassegrain focus you can just see here a couple of instruments. These are actually two instruments in one, two instruments at the same time. You have here a big one which is PMAS. This is an integral field spectrograph. It means you can take something like 250 spectra in one shot at the same time, because you have these 250 fibers in a bundle to observe, for example, galaxies or nebula, extended object. The field of view is 1 arcminute. It is as large as the Muse integral field spectrograph, for example, or the VLT. Of course, the telescope is a bit smaller, but still, it's very efficient. And there is a niche for PMAS in particular in the blue. It goes down to 3,600 angstrom. This is much bluer than what you can reach with Muse. So it's really working very nicely, and we use that, for example, for the Khalifa Legacy Survey, which was a big success here for the Observatory of Calar Alto. But at the same time, you can see above me this ring, this black ring with the Carmenes logo. This is because here you have the front end of the Carmenes instrument. Carmenes is another spectrograph, but a very high resolution one, with only 2 fibers to observe one target and get calibration at the same time, because Carmenes is thought to detect in particular exoplanets, very high resolution study of stars and this detection of exoplanets. The accuracy of Carmenes is really impressive. This is 1 meter per second. Somebody walking like me at 1 meter per second, but hundreds of kilometers, hundreds of light years, away. How to reach this impressive accuracy? For that you need to put the instrument Carmenes in a very stable environment. And the ideal place for that is to put the instrument in a very stable room. We put that here below. Under me you have this former Coude room, which is very well stabilized inside another room with a temperature stable at the order of 1/100th of the degree. And inside this stable room you have the vacuum tanks of Carmenes, one for each channel. This is a peculiarity of Carmenes, which makes it unique still in the world. You have a visible channel, and then you have a near-infrared channel. It is useful in particular, this near-infrared channel, to study the atmosphere of these exoplanets. You cannot even see, but you can know that there is, for example, helium evaporating in the atmosphere of this planet. Let's try to move now the dome. You can see here already this impressive view of the 3.5 pointing in this mirror. Here you see just the support of the mirror. When we have to illuminize the mirror, we just put it here and we go down. We set that after that. This is a big piece of glass. Let's try to move the dome. For that we're going to use another old-fashioned, old design console, which is working just very nicely. Let's switch off the lamps. You have a bunch of buttons, one action again, but it's just working very nicely. And let's try to move the dome right here. right? It's a bit noisy. The telescope, when it's moving, it's not noisy, but the dome itself, yes, it is noisy because these are hundreds and hundreds of tons of steel moving. We are not moving. The dome is moving. You can see the size compared to the person here. This is very, very impressive. And from here, from this console, you can see, you can guess to the mirror right here at the bottom of the frequency. Now we are speaking about the mirror. I think it's a good time to go down to the illumination room, which is on the ground floor of the frequent flight building. Let's go down something like 30 meters below to see this illumination facility we have here on the frequent flight ground floor. Let's wait for the lift and let's see if we can go down. It will take some time. I hope you appreciate this view from inside the dome. Let's now go down to the 3.5 illumination room. It's taking a while. Let's see if we can go down. Right here it's coming. And let's get inside. See you in a minute or so. Bye bye.
Cierre de puertas. Doors closing. Bajando. Lift going down.
Okay, so now we are on the floor ground of the 3.5 building. We can just get in the illumination room. You can see here this kind of huge swimming pool, which corresponds actually just to the place where you put the mirror, the big mirror. You can see this is like a very nice support here to support the mirror. You put it inside this big piece of glass. Then you move this here, everything below the illumination bell itself. So we are getting in. You can see this is a pretty surprising place, like a huge bell, something like 4 meters in diameter. You can see here above the cathode, which is used to clean up the mirror. The idea actually is to put the mirror inside, already pretty cleaned. Then you put a huge voltage here with the cathode to do a kind of plasma inside the mirror, inside the illumination bell. And then this cleans everything, absolutely everything. Then you close everything and you create a pretty good vacuum at the level of 10 to the minus 6. So this is quite a good vacuum. And what happens here, I'm not sure if you can see here, these pieces of aluminium here surrounded by resistance. So you put the voltage inside the resistance, the aluminium is melting basically, and then it's evaporating. Every atom of aluminium is evaporated. It falls down slowly over your piece of glass, over the mirror. It is deposited with a perfect accuracy one by one. The process itself takes a few hours. Here we do that every one year and a half basically. We re-illuminize the mirror of the 3.5. We have also another illumination bell on the 2.2. These are facilities open to the community. It means that here in Calar Alto we illuminize, in addition to the sunrise solar balloon Jesus was speaking about at the beginning. Then we illuminize to the largest telescopes, largest spatial telescope, the ESA Herschel telescope. It was done here because the mirror is right the same. You see the 3.5 meter in diameter. So it was illuminized here. We can say that we sent aluminium from Calar Alto to space. Also, we illuminized mirror 2.5 meters for a telescope in Russia, another one in China, and we are currently preparing the illumination of a 2.6 meter for telescope to be installed in India. So we are sending mirrors freshly illuminized everywhere around the world. So this is really a nice facility in an impressive place, and I think it's a good place to finish, time to do the vacuum ourselves, and I hope you appreciate this visit of Calar Alto. And let's go back to the sky now. The visit is over, but in a minute I will reply to your questions live. Meanwhile, I would like to show you how the sky looks at Calar Alto at night, so we'll have a nice time lapse in between. See you in a minute.
Okay, amazing. This is awesome video from Calar Alto, folks. So now it's time for questions if you have any. Gilles is here with me, so I guess someone can just do the video on spot, the video spot on Gilles. I think maybe me. Okay, so Gilles is here. I've seen this kind of discussion about colors in in Discord, but in Zoom I don't know if there are some questions there.
Yes, there were a few questions about color. Basically, the white for the doves, of course, is to reduce the solar heating during the day, to maintain a good temperature equilibrium between outside and inside. And the blue is probably a German taste because our instruments were done by Zeiss. So it's a good telescope, good, excellent optics and mechanics.
Yeah. So there's a question from Peter Skoda. He says that he has a 2 meters mirror. Well, they have in Ondřejov a 2 meters mirror telescope, and he would like to know how much would cost to get it realuminized in this large tank, and how long in advance it must be arranged.
Well, I cannot give a price myself. We have to talk with the department head of the mechanics department, but I think we are pretty good quality price since ESA, for example, sent us the mirror of the Herschel spatial telescope. So it's just a 3.5 meter telescope like ours, and they send it directly. The point is that since we are located inside continental Europe, it's so easy to send us material. We can just put the mirror, big mirror, in a truck, and one day after that, it arrives here and we can illuminize. It's not so dangerous as being on an isolated island. So it means the cost in particular for transports are cheaper.
Is here also Roberto, who tells us that wants to know if you can observe remotely.
Yes, we have a couple of telescopes that are being used remotely, the smallest one actually, because these are, let's say, the simplest one. We have the former Schmidt telescope, which is used currently by ESA. We have a exclusive contract with ESA to look typically for spatial garbages, NEOs, things like that. So it is used remotely. You just prepare your Python script, and automatically it can be observed with your script. And then on the other hand, we have a 1.2 meter telescope, the first one installed on site in something back in 1975, but it's still working perfectly. It was the largest telescope in the Republic Federal of Germany by this time. And it's being used by Germans, by Italian people, remotely from Roma or Berlin or from here in Granada. And this telescope also is very useful for training of students. Here we have a commitment at Calar Alto to offer, to have young people having hands-on on the telescope. This is something you cannot do on the VLT. But here our commitment is to offer the main Spanish universities in particular a couple of nights of training with the 2.2. So students can just come here and touch the telescope, move the telescope, focus, take an image, a spectrum. And this is important for us. We are using that with the 2.2 telescope too. And about the fully remote operation, we're thinking about that. It's a bit complicated because we have some complex instruments like PMAS. We are currently observing with PMAS. This is a large integral field unit spectrograph, and you need at least 3 or 4 screens to be observing comfortably. So we are thinking about that maybe in the future. But at the moment, we do think that it is important to have professional observers on site to check for the weather, to have any technical issue. We have a permanently controlled people here and taking care of the telescopes. I mean, our telescopes are pretty old, but they are just in a perfect shape. We are only losing something like 1% of the time for technical time lost. So it's a good sign.
Okay, thanks very much, Gilles, for this visit. So there are still some questions in Zoom. I think you could see them. And anyway, you could be, you also are in Discord, and your people are in Discord. So if you want to ask Gilles some question, he can easily answer you through in the chat, the Discord chat. So I think it's time to go on the conference and for the next session. So thank you very much, Gilles.
You're welcome. See you soon.